Good morning, children. Let's enter into the third day. In the last session, we have learned about contact forces and its types: muscular force, frictional force, normal force, and tension force. And in today's session, we will be learning about field forces. Field forces are also called as non-contact forces or force at a distance. Now, let us discuss the forces which falls under field forces. They are magnetic force, gravitational force, and electrostatic forces. Today, in this session, we will be learning about these three forces which falls under field forces with the help of the examples. Let us first go with the magnetic force. You have already learned about the magnetic force in your 6th standard first unit, playing with magnets. Magnetic force, this force is exerted by the magnet. When I place a bar magnet near iron nail, your iron nail gets attracted to the magnet. This magnet pulls the iron nail towards it. Here, pulling happens. The effort of pulling the iron nail by the bar magnet towards it, I can call it as force. As this force is done by your bar magnet, I call it as magnetic force. See how the magnet is able to exert some magnetic force. Can it exert force wherever it is placed? For example, let me have a magnet in my hand. Now, iron nail is fixed into the wall. Now, if I hold the bar magnet in my hand, will the iron nail come in, is pulled by the magnet and come and attract to it? No. That means magnetic force can be acted only around certain area around your bar magnet, which I call it as, that means here when the bar magnet is placed, there will be certain area or space or region around the bar magnet where it can exert its magnetic force, and I call it as magnetic field. It is called as magnetic field. Here you can think about why the area is called as magnetic field here. The field is nothing but certain region or space around the magnet where magnet can exert some force. Okay, so this region is called as magnetic field. So in the influence of the magnetic field, magnet can pull iron nails or magnetic materials, I can say, by exerting some force which is called as magnetic force. Coming to the next, we can also have an activity by having two bar magnets. See, let me keep a bar magnet. It has two poles, north and south. Let me bring another bar magnet having two poles, north and south. Now, what do you observe if I bring two bar magnets closer to each other? Definitely you will observe this bar magnet will attract the another bar magnet. Now I'll have some change in placing the bar magnet. Now I can place the bar magnet like this, facing like poles facing each other. Here unlike poles facing each other. Now you tell me what happens in your second case. In the first case, magnet got attracted to the first magnet, but in the second case, you will observe these magnets repel each other because like poles are facing each other. South and south, same poles never attract each other. It is learned already that unlike poles attract each other, like poles repel each other. So, by this pulling and pushing, the effort done by the magnets, by exerting some force, I can call it as magnetic force. So these are the examples which we can explain by using them, which we can explain about the magnetic force. Coming to the gravitational force. Gravitational force is known to everybody. An apple falls down from the tree directly onto the ground but doesn't fly in the sky, right? Why do you think? I want to throw this chalk piece into the sky, and I want my chalk piece to stay in the sky, but will it happen? I want my chalk piece to stay here in the sky for 5 minutes. Can I do this? No, because it is pulled by your earth. Why do you think all the things are falling down? Where if I keep anything if I place like this, will it be there in the sky? No, never. It will fall down. It is because of Earth's gravitational force. See, do you think only Earth attracts all other objects? No. From the universal law of gravitation, every objects on the universe will be having some force of attraction between them. For example, we see many objects here in the classroom: the board, fan, wall, bench, nail, my watch, you, me, teacher, blackboard, many things, right? All these things have some force of attraction between them. That means the blackboard and myself has some force of attraction. But if that is true, I would definitely stick on to the blackboard, because as there is force of attraction, I have to fall onto the blackboard. But it is not happening. Why do you think it is not happening? Though there is force of attraction between all the objects, the force of attraction is very less, that is negligible. That's the reason I will not attract, or why I will not fall onto the board like lizard. Okay, even you and me also, every other object, you and me, fan and me, wall and me, door and me, anything, any two objects if you take on the universe, every two objects has some force of attraction between them, but nothing is attracting. I am not attracting to the wall, or you are not attracting to me. Why it is this? Only the simple reason is, though the force of attraction is acting, but it is very small, so negligible that we cannot attract each other. Then why it is happening with the earth? Then your doubt must be, why all the things are falling onto the ground then? If I throw a ball into the sky, it has to be in the air only, but it is not staying there, it is falling down. Why do you think it is falling down? Simple. Earth is a massive, Earth is so massive, it exerts lot of force of attraction. As the force of attraction exerted by the earth is so huge, that's the reason all the objects, things are falling on to the ground. Is it clear? So here we are discussing about the gravitational force under field forces, because when I throw the object, the earth's surface is not holding the object and pulling it towards it. It is not happening. Like in Rajnikant movie, nothing is coming, robots are not coming and pulling down, right? Nothing is happening, but simple and invisible force, though it is apart. They are not touching each other, but still some force is acting between them. We can see such examples, right? Let's have fun in the classroom. See, some students will be so timid. If I see, look very, don't do that, get out. If I say, he will get out. But some students will be there, I have to go, pull the collar and then kick him out, right? Stubborn still. So here, two things. Force is acting on in two cases. But here, with eye contact only, he will go, the number one student. Number two students, I have to pull him and throw him out. That means, physically, contact is existing between them. So, here in this case, though the earth is not in contact with the surface, still the earth is exerting some force on the object. Hence, your gravitational force comes under field force. Got it? Coming to the third force is electrostatic force, which is your favorite, which will be your favorite. Just listen to it carefully. You might have all played with this game, right? You usually take a scale and you rub it to your oily hair and then try to attract it to the pieces of paper, and the pieces of paper attracts to your scale, right? Do you think? Did you play any time? Did you think why the pieces of paper will attract the oily scale? Okay, let's learn about this. See, to understand more, you take a balloon, inflate it with air. Now you rub it to your hair, oily hair. What happens on rubbing? On rubbing, because of friction, when you are rubbed, the surface of your balloon gets charged. It is being charged when you rub it. Now this charged balloon, when you bring to nearer to the bits of paper which is uncharged, it gets attracted. What do you think? What is happening here? A charged body is attracting an uncharged body. So if a force is exerted on a body by a charged body, I call such force as electrostatic force. Did you follow me? Let me revise it again. Electrostatic force is that force which is exerted by a charged body on another uncharged body. That means if a force is exerted by a charged body on uncharged body, I call that force as electrostatic force. Okay, so here I am not attracting, the bits of paper and your inflated charged balloon doesn't come into physical contact. Physical contact means the two surfaces doesn't touch each other, but still there is some force is acting on it which is pulling the bits of paper towards it. I can call this force as field forces because as there is no physical contact exists between the two surfaces. Is it clear? So let's revise. This is up to, in the session we'll learn up to here itself. So field forces, as already said, if there is no physical contact exists between the two interacting objects and still the force is caused, then I call that force as field forces or non-contact force. Magnetic force, gravitational force, electrostatic forces are those forces which falls under field forces. Magnetic force is a force which is exerted by a magnet by the influence of the magnetic region or magnetic field. Gravitational force is a force which is exerted by the Earth's gravitational pull. And coming to the electrostatic force, this force is exerted by a charged body on uncharged body. Okay, we'll end this session with a small homework. Please write down, today's homework is write down what is field forces, then comes under what forces comes under field forces and explain them with small activities. Thank you.